Thank you so much. It's really good to be here. This is number 3 for me in terms of GraphQL Summits, third year in a row. I'm really excited to be here again. And I want to talk to you today about the database layer. This is going to be a talk that hopefully complements Will's talk that he just gave to maybe give us all some ideas around what we might do if we have control of our database, if that's something that's in our hands and we're able to maybe use that info object that Will was talking about to make more efficient queries. That's the idea today. So as Jake mentioned, my name is Ryan CHENKIE. I'm a full-stack developer. I do a lot of work as a consultant building applications for companies, doing a lot of React and Angular, Node, and of course GraphQL. And I do a lot of stuff with Google for their Developer Experts program as well. So, question, why do we all love GraphQL? I mean, everyone's got their own reasons, but some of the typical ones might be things like discoverability if you are you're developing a client application, right? We can peer into the GraphQL API that we're calling into and see what's available. We've got these client-server contracts. The server is able to say, I have these things, and the client is able to say, I want these things, and they're able to communicate with one another to ensure that what the client application wants is something the server can give back. And I think another one that we all love would be the efficiencies that we can get with GraphQL. So things like not needing to make multiple round-trip requests, not overfetching, getting back only the fields that we want, that sort of thing. And it's that last one that I would like to touch on today to see how we can maybe make things more efficient. So when we make a query with GraphQL, as we probably know, it resolves with exactly the data we want. We ask for a certain set of fields, and we might get back only those fields. We should get back only those fields. But what about the database? Now, depending on how our resolvers are set up, which kind of data sources they're calling into, it's maybe not always the case that we automatically get only the fields that we ask for from the query. So we might get these efficiencies from the client layer to get back only that data that we want. But on our back end, things might be inefficient in some ways. So the question is then, how can we use GraphQL to improve our database queries themselves? And there's a few use cases that I want to kind of go over. So caveat here, these are kind of bare bones use cases. These are things that are not super well fleshed out. The code examples here you probably don't want to go put into production right away, but they give us a really good glimpse of how things are going to sort of work under the hood if we have control over our GraphQL server and, more importantly, control over our database. So the first one we'll talk about would be scope selections. So that would be taking the information from the GraphQL query itself and using that to inform our database which fields it should give back. We'll talk about sorts and limits for sub-selections, so basically passing arguments into kind of a sub-selection of a query. We'll talk about auth info, so how we might intersect auth info from something like a JSON web token to build out a query for our database that's a little bit more efficient in terms of how a developer might interact with it, for example. And then the last one, which is kind of interesting, would be protection from deeply nested queries. So if you've got any data that is or maybe say two kinds of data that reference one another in a circular fashion, how we can protect ourselves from deeply nested queries. So note on these examples, we're using MongoDB here for example, but it's applicable anywhere. This is just kind of my database of preference, and it's one that's good for showing examples, but the same concepts can be mapped basically to whatever you are using. So it is all about the AST, the abstract syntax tree. So this is a big topic, lots of different ways to apply ASTs to computing. Lots of, it's a very, very rich topic. We won't go too much into it, but essentially I'd say that there's code for humans, there's code for us to understand, but then there's code for computers, or maybe programs is the better way to put it, to understand. And to see an example of that, here's a GraphQL query. We probably are familiar with what this does. Asking for a books resource, getting 3 fields from it. What GraphQL wants to do, though, is it wants to take something more like this, something that is way more fleshed out with much more information about that query. So what you can see here is that it's a giant object, essentially, with lots of different fields that inform what that query represents. So things like a field itself with a certain kind and a certain value for that, a set of selections that would be found on that field that is being queried for. And so this is something that can be better understood by GraphQL. So we take that GraphQL query, we translate it into something that the computer or the program can understand, and that something is the AST. So abstract because it can be anything, syntax because it has to do with programming syntax, and tree because it's essentially just a giant tree structure. So it's a big object with many layers of nested objects within. So ASTs are useful for us here because we can sort of extend GraphQL's capabilities. We can do this programmatically. So we can traverse over this AST, we can pull information from it, we can augment a query programmatically, and that's kind of what we want to do here. So the question is this then, how can we interact with it? And if you were in the last talk, you saw that Will told us we've got this fourth argument here in our resolvers. So we've got this info argument, which is where we would find the GraphQL AST. And so many very useful pieces of information on it. Will touched on some. The ones that we'll sort of look at for our purposes today would be these guys: field node, selection set, and selections. So this would be stuff that might be, at a first pass, relevant to you as a developer if you want to interact with the AST. And so this is kind of how things map together, right? We've got books mapping to this first field node here, which has a kind value of name. It has a value of books on there. We've got a set of selections underneath. And so these things map together here within the AST. So lots more information is out there about ASTs. I'd recommend some resources here. I just put them in some bit.ly links for you to grab some nice articles that are particular to the GraphQL AST, but ASTs in general, a very, very wide-ranging topic. OK, so let's look at some examples. Scope selections to start out with. So let's say we make a query from our front end. We want to get back those three fields: title, author, and publish date. Well, this is what we get back. We expect to get back only those fields that we query for. But maybe this is what the database gives back to the GraphQL server before giving that information back to the client, right? So here we've got, not such a big deal, 2 records, 7 fields on each. But if you are really using Mongo to its full capabilities, this could be way bigger. I think document sizes in Mongo are capped at 16 megabytes per document, which, I don't know, that's a little bit wild to use a document of that size. But the point is, we could have a set of data that's way bigger than we actually need passed back from our database. So let's use the GraphQL AST to only get the data that we want from the database. So what we want to do essentially is take this query here, books with those 3 fields, and we want to turn it into something that looks a little bit like this. I'm using a library called Mongoose. It sits on top of Mongo, gives a nice API for making queries and that sort of thing. And we want to select only those fields that we've actually queried for from the client. And really all that comes down to is turning whatever those selections from our client query are into a string that we can shuffle off into our database call. So we might have a function that looks a little bit like this, something like get query selections. And it's going to operate on that field nodes key and just kind of map over it, take the selections, flatten it, get the value, et cetera. Very quick and dirty way of doing this. There's many more contingencies that you would need. Things like, what about if you have subselections that go deeper, right? So, but this is a very kind of rudimentary way of putting together that string. So then what you do is in your resolver, you can just say, let's get those selections from that info object. And then in that get books call, which delegates to a database call, we could just pass in those selections. And what we've got is this string that just has title, author, and published date. So this is a good way to take the info that you already got from your query and use that to inform your database call itself. OK, let's talk about sorts and limits, specifically from subselections. So we can get arguments right from a GraphQL query if our schema is set up such that we accept arguments in a certain field, for example, we can do something like this, right? If we've got contacts, we can have this argument of limit, only give us 10. It would be easy in this case to grab that argument. It's on that second argument there. We'll call it params, also called args. You can get that right away. You would have this object with a limit of 10. However, if you were to do something like this, where you want to set a limit on that sub-selection, well, you're not going to be able to get that information in that second argument like we did just previously. It's going to be an empty object in this case. So what do? Well, lots of different ways you can set up your resolvers to maybe interact with one another. But if we have access to that AST, we could, for example, map over what's in there and take the arguments. So because the AST has very specific info about what each piece of the query is, we can look for anything in this last line here where we're filtering with a kind that is equal to argument. Again, quick and dirty way of doing this, glosses over a lot of detail, but you can get those arguments like this. Maybe we set up another function where we say we want to get the limit. And so we look over those raw arguments that are passed into that sub query, and we look for anything with a value of limit. We pass that back, and now we've got something that we can send to our database query to get that data with just a limit of 10, for example. So a good way to limit the amount of data that's going to come back. OK, intersecting with auth information. So this one's interesting because there's different ways to set up your application, obviously. There's different ways to set up your database as it pertains to your use case. A common one that I'm seeing is if you've got like a maybe you wouldn't call it a multi-tenanted app, but if you've got an application that has many different users in it that are each unto themselves in different organizations, you've got a couple options. You can set up maybe a different database for each tenant. For a lot of organizations, that's a little bit overkill. Maybe they just want to have like one database, but separate the data based on keys, based on like IDs for each tenant. And that's something that we can use GraphQL's tools to help us maybe get a good layer to help restrict calls to just the clients that are asking for the data. So we don't always need to use ASTs when we're doing stuff. There's other tools within our GraphQL resolvers. And in this case, we might just want to use that second argument, so taking arguments. And we might also want to use context. So GraphQL gives us that third one called context. And if we're using JSON Web Tokens, I've spoken about this in previous years, how to kind of tie together maybe an authorization layer to your GraphQL server. One way to do authorization is to use JSON Web Tokens. In this example here, I've got a token that's got a payload with a client ID in it. And so that client ID, perhaps that is like, belonging to a specific organization or group that is within your application. Maybe you've got users underneath that organization that each have their own sets of data access, but maybe this one's just for a particular organization. What we can do is, we can do this actually in the kind of server setup phase, is we can set up some context to grab that client ID from the token and make that available on our context. So what we're doing here, we've got this getClientID function. That's going to take that authorization header, and it's going to do some things like verify that it's valid. It's going to then decode the payload and get that client ID. And if you're a bit unfamiliar with JSON Web Tokens, and you're worried that maybe someone could come along and change that client ID and try to spoof themselves as another user or another organization, as long as we're verifying the token with a strong secret, we're safe, because anytime someone goes to change the information that's in here, it's going to invalidate the token. So we're safe in that regard. And this helps for us to have a nice stateless setup within our application, because we can just trust that information that's coming in from the token, and then we can delegate to a database call and pass that information along. So here's kind of a contrived example, if you will, of how you might put this together. Maybe we've got some resolver that takes an argument called starts with. So maybe we want to look up some data that starts with a certain value, right? And we want to intersect that with what that user is allowed to get to. Well, we could take, we could take this starts with argument, put it on a message. Maybe we use the regex operator there with Mongo. Definitely wouldn't recommend doing it like I've got it here, because you want to make sure that you're not allowing the client to put certain things into a query to have kind of NoSQL injections. But this demonstrates how you could do it. You would kind of then make a scoped query. You would take that query along with your client ID, put that together in a single object, and then shuffle that off to your database call. And that's your query. So this last one we'll talk about, defending against deeply nested queries, is pretty interesting. There's a really good article put together by Max Stoiber. He's a developer that started a company called Spectrum. You might be familiar with him. He put together this article talking about things they needed to do or that they came across that they wanted to kind of defend against with their GraphQL API. And one of them is that they had data in their API that was kind of self-referential with other things. So you might have, like, for example, a set of posts that have an author, and those authors have posts, and then those posts have authors, and it just goes deeply nested like that, meaning that it could be a perfectly valid call for somebody to make a query like this that just goes posts, authors, all the way down ad infinitum. And that is not a great thing, because you can have somebody essentially DDoS your API at this point. Because the more lookups you have to do when this query comes in, the more computational power you'll have to extend. So what can we do? Well, we can use the AST to see how deep that selection set is. So what we've got here is a nice little function that is recursive, and it's going to take in the node that we're currently on. It's going to keep track of a current depth, and it's going to see if we are exceeding a certain depth. The way that we might use it then is we might have something like this. We would get our selection depth based on our info argument, and then if that selection depth is greater than a certain amount that we want to allow, we can error out. This is kind of what this library does, actually, GraphQL depth limit. And so this is a library that's ready to go for you. It covers way more of the details that you would need to cover. And this is something you can just plug right into your schema setup level. And you can specify a depth limit. You don't want your data to be queried beyond 10 layers deep, for example. And that's going to be really useful for you to protect against that. So we have got a few ways here, maybe ideas of how you might make your database queries more efficient. But there are some limitations. One of them that I can think of is that at this point, you're kind of coupling to, you're coupling to the database layer, coupling GraphQL to your database in some way. If you've got full control over your database and things aren't changing that much, this might not be such a bad thing. But it does introduce this dependency that you've got where it might be hard to break away from at later points. And another limitation is you might not actually have full control over your database. Maybe you've got to, in your resolver, make a call to another API. Maybe you don't have that much control over your database to begin with. That can make things challenging. So who's doing this in practice? I don't know the super in-depth details about who would be doing this in particular, but I know that Tanmai here is going to talk to you next about how Hasura uses some of these principles to construct really efficient queries, particularly with Postgres. So he's going to talk to you about that next. And then a lot of the ideas that I took here are actually from this library, Mongo GraphQL Starter. This library does a lot. It's kind of like, it's got things to auto-generate code, but it also takes a lot of the things that I talked about to construct way more efficient queries for MongoDB. So have a look at that. That's a really good library to get some more inspiration from. OK, so I'm almost done. It's a little bit early, but I've got some treats for you before I go, since it's Halloween. This is the first one, slides and code. So if you want to take a picture of this slide here, this is where you would find, firstly, the slides. Secondly, basically a project that's ready to go with examples of how you would do each of these things. So check that out. The second one is I've got this tutorial site that I put together some time ago called trygql.com. And it's kind of like an interactive tutorial. Takes you through the basics of GraphQL. So if you got colleagues that haven't touched GraphQL at all, it's a good starting point for them. But it's fun to do even if you're experienced with GraphQL too. Next one is something that I guess launches right now because I haven't really made super big announcements about it yet, but it's something called Graph Collective. And Graph Collective is basically a site that I'm putting together that is going to feature, or does feature, because it's here now, lots of different folks within the GraphQL community telling their stories about why they use GraphQL, what benefits they get from it, why developers tend to love it in general. And so the hope here is that if your company maybe is on the fence about GraphQL, maybe if they're not so sure about it, this will serve as a kind of a case study point where you can have maybe your manager or your manager's manager go and look to see why GraphQL is beneficial and some of the success stories that exist in the community. So I'd be super, super stoked if you could all go to graphcollective.io, and that's going to redirect you for now to YouTube, where you can subscribe to the channel. And also, if you want to follow on Twitter, it's @GraphCollective there. So yeah, I'd be super stoked if you guys could check that out and pass it around. But that's it. So thanks so much for having me today, and I'll be around.